Good morning. Is everyone awake this morning? Are you still on, if you're from Houston, still on Central Time instead of Eastern Time? Anyway, that was an excellent presentation that Robert gave, very concise and to the point. Thank you, Robert. Anyway, just to go through the presentation I plan to go through with you today is very similar to one 2 years ago here in Arlington that I gave to the gas transmission folks. In fact, it was in August of 2013. We have not started, as Ken and Alan said earlier, working on anything as far as any proposed rulemaking or anything on the hazardous liquid. In fact, the presentation I plan to go over will be very similar to the gas with some tweaks based upon looking at liquids versus gas pipelines. So anyway, here I'll go through it. First of all, what do we plan to talk about today? As you can see up there, we're going to talk about liquids IVP process, some of the goals, what the process is, the flow chart that you've seen. I'll talk a little bit about it. And then some other Part 195 updates that we're looking at that we think need to be in the code based upon a lot of questions and other things outside of integrity verification that we've seen. And then I want to talk a little bit about the impacts and benefits. Just because we talk about something might be in a proposed rulemaking, I want to go through what the process is. In other words, we'll get comments from you on our docket from today's meeting. Then if we decide to do rulemaking, we'll go through, look at those comments. We'll go through a write-up within PHMSA, technical, legal, and then from there there's a routing process through the government before it's ever released. It goes to the Office of the Secretary of Transportation and then over to OMB before it goes out. So, and I'll go through a little of that, what we look for during that process. First of all is again the integrity verification process is basically verification of your MOP and material records. We're looking at, have you pressure tested your pipeline? Do you have adequate records for your material documentation? If you go back and you look at Part 195, 452 on IMP, you should already have this information. If you're properly doing IMP, really this right here should just be a given, what I'm going through today. The third bullet here is reevaluation, the risk-based alternative that was used instead of pressure testing. You know, if you go back and you look at that, it tells you which pipelines you can't use the risk-based option on. I think it has in a low-frequency ERW pipe, and it also has lap-welded pipe. But what if you have flash-weld pipe that's acting just like low-frequency ERW pipe? I realize it doesn't specifically say that it's you can't use the risk-based option, but should you be if you've got pipe with seam issues that are acting just like low-frequency ERW? Then also, if you do have cracking issues, how do you do a one and done? You're pressure cycling your pipeline. Are you doing a fatigue analysis and retesting or rerunning ILIs based upon what that analysis tells you? And then again, I'm going to talk about some other possible updates that we're looking at for Part 195. Where should HL-IVP be applicable? Well, I think the obvious is in high consequence areas. And which non-high consequence areas should we be considering? Should we consider rural gathering lines that could affect an HCA? Should we look at interstates, freeways, four-lane highways? Should that be part of it? Should HVL pipelines be in it? And then where should we draw the line? Should it be 20% and above SMICE, below 20%, 30%? You know, where should that cutoff be? And then looking at, as Robert talked about earlier, just going back and highlighting some of the gas transmission drivers, should we consider some of them for the liquid pipelines? And again, here's some of the mandates that we got is on the gas side, you can see requires either pressure testing or an alternative equivalent means, such as an ILI program, if the pipe has not been previously tested. Should we be doing something like that? The next bullet I've got there is, what do we do if you do not have records for your MOP? What type of strategy should you have? You know, if you go look at the code right now, it tells you what you should do if you don't have records. If you go look at 195, it tells you how often you need to be destructively testing pipe. But we realize that that may be impractical. But let me ask you this. Do you know or have a friend that's ever bought another system and they don't get any records on the material? They don't get any test records. Well, to me, if you do something like that, should you be able to do this? In other words, should you be having to go by the code, and it tells you what you have to do there. The next was the NTSB recommendation on delete the grandfather clause. In other words, what we should do there, like on the risk-based alternative. Should there be a pressure test, including a spike test? And then the last is seam stability. If you've got seams that are not stable, what should you do there? And I think all of these, it may be that the mandate wasn't directed for liquid pipelines, but I think the liquid pipeline industry has similar issues, as Robert said, as the gas transmission. In fact, you probably cycle your pipeline more, that the issues may come to the surface more. I realize on some of the incidents that I'd like to call it like on the price of your house, location, location, location. Some of you may have been lucky that you weren't around a stream or a populated area, if you've had a rupture or a leak, that you haven't had the issues that some of your other operators have had. And just looking at that, let's look at some of the facts from the PHMSA's database. Since 2002, you know, what have we seen? And this is all material defects, construction defects, and you can see there's been 154 in our database. 52 of them have been low-frequency ERW and flash-welded pipe. 8 of them have been lap or butt-welded pipe. And there's been over 330,000 barrels of product spilled, approximately 2,200 barrels per incident. Again, what are the drivers? And if you look at these stats a little more, is you can see 9 of the accidents, or incidents, whichever term you want to use, have been greater than 10,000 barrels. 30 of them have been between 1,000 and 999. In other words, 25% of the accidents have been greater than 1,000 barrels of the 154. So you can see the stats that I've got up here. I guess the thing is if you're not doing some of the things Robert talked about and I'm talking about today, can you go to your management? Can you go to your stakeholders and to the public and say, well, of these incidents we have, 1 in 25 could be over 20,000 barrels of product spilled. Go to your insurance provider and tell them that, hey, this is what it could be. See what happens there. Again, looking at the infrastructure, there's 199,000 miles of liquid pipelines in the U.S. About 5,000 of them are offshore, 194,000 onshore, and the breakup there is 83,000 is high-frequency ERW, 47,000 is low-frequency ERW. In PHMSA's annual reports, we do not get information on other seam types. I wished we did, and broken down by diameters. It would really help on this, but we just don't have that information. Also, looking at this, is about 48% of the pipeline infrastructure was built pre-1970. And you can see also about 15% of it was built in the 1970s. So just to give you an idea of the age of the systems. Some of the basic principles that we're looking at on the liquids IVP. Again, just to highlight the next several slides that I'm going through, what are those 4 basic principles? Well, first we're going to look at the higher risk locations. And we need your input on what should those be. We haven't decided, from our vantage point, what they should be. Screen the pipe segments for the categories of concern. In other words, if seam cracking is an issue, stress corrosion cracking, if wall loss anomalies are the issue, look for what the issues are. Do you have adequate material documentation? And then perform the tests and the integrity assessments needed to establish the MOP and also to do your assessments. And getting on to these 4 items I just talked about, let's go just a little bit more in detail. And let's talk about the principle 1 or category 1. Apply to higher risk areas. I think the obvious is we want it to apply to HCAs, could affect to segments. I guess the other thing is, do we want it to apply to all of the main line? Should it be 100% of it? Of course, I think we want to consider the roadways, the freeways, the 4-lane highways, all of the heavy traffic highways. Then the next item is the rural gathering that could affect an HCA. Do we want to include those? And then the HVL pipelines, and as I said earlier, the non-high consequence area pipelines. And again, PHMSA doesn't have information on what's in each of these categories. We do know that onshore there's 194,000 miles of pipeline. Principle number 2, screen for categories of concern. Okay, we're going to apply the process to which type segments. 1, it would be pipe without a pressure test. Number 2, it would be pipelines with a history of manufacturing and construction defects. You know, just to give you an example there, if you're an operator and you've got a pipeline and it may have a seam type or a coating type or a vintage type that's not specifically in the code, says you've got to do this. But let's say you're having ruptures on the line. You're having ruptures that are 1,000, 5,000 barrels. You might even be having multiple ruptures in 1 or 2 years or 3 years. To me, I don't think you should need a rule to go do something, to do additional evaluations on that pipeline, assessments and remediation. I just don't think we should have to do this. You should already be doing it. Legacy pipe, do you have a valid spike pressure test? A 1.25 times MOP is not a valid spike pressure test in my opinion. But what should it be? I think that's the answer. And how long should it be? Should it be an hour? Should it be 30 minutes? Should it be 15 minutes, 10 minutes? Or should we let the operator just pick whatever it should be? I think we should have a minimum, but then let the operator, if they want to go well above that, let them do what they want there. And again, we've, as Robert had gone through on their PG&E information, PHMSA did issue an advisory bulletin on the reliable, traceable, verifiable, and complete. And there's the advisory bulletin number. And when we get through here, my slides, Robert's, and everyone's else will be on our website or be on for the docket and for this workshop, so you'll be able to get this and look at it later. Principle number 3, know and document the pipe material. If you've got missing or inadequate material, how do you establish the properties of that material? Are you going to test the pipe samples like the code says, which I think if you go look, it's a pretty tough standard. Or do you do some type in situ non-destructive testing? If you do that, it must be validated in code or PHMSA approved. You know, what I'd recommend, if you've got these issues, I would not wait for a code. PHMSA will gladly work with you as far as coming up with criteria that would meet whatever we're looking at going forward with here. We have worked with some operators that have had this issue, and we have put in situ non-destructive processes in place. One, I'm of the opinion you've got to walk before you run. So, you know, some of it has helped us get information on what good processes are and what bad processes are. You need to do field verification, not only on the pipe, but the valves, flanges, fabrications. You may not even know what the fabrications are good for pressure-wise. And then, again, what other verification should we consider? The last thing in these principles, number 4, is test and integrity assessments. I think this is very much a key one. Is what do we do? And again, you'll see in the chart we've got in the back of the room, and that you've probably gotten a sheet on it, is we've listed some things to be considered. Now, some of them may be better than others, some may not be good at all. But again, if you're pressure testing and you're doing a spike test, again, and you've got legacy pipe, which I'll give you a definition from gas transmission a little later in this, or if you've got it with manufacturing construction defects that's got a failure history, what should that spike test be? And not only duration, but pressure. And if you derate the pipeline, how much do you derate it, and how often do you look at that? Can you continue derating it, or is it just for a set time period, and then you have to do something else? Engineering critical assessment. What is an engineering critical assessment? If you're using inline inspection tools, how do you verify them? How do you make sure you're getting good information? How, when you go in the ditch and you dig up the pipe, how do you tie everything together? And then replacement. I think replacing the pipe's always an option. I'm not saying we're going to direct anyone to do that, but that's always an option. Alternative technology. Again, I've learned is when you come out with new rulemaking and you start discussing this, there's always entrepreneurs that will come up with new alternative technology to help out. And any other options that we should consider. Again, just going through, I want to just touch base for a second on the chart. Will you hand me that chart? If you've got a copy of this, if you got it at the front desk, you might just look at it as I go through some of this. I'm going to go through fairly fast. That's not what the presentation today is about, but I want to give you an idea of what we were trying to do here. Mainly, this is a 13-step process, and it's more so to just give the steps that we were looking at. If we should go into any rulemaking, how we wind up really doing this, I don't know at the present time. But anyway, what we want to do in this process is screen for high-risk pipe, and that would be in the first 2 steps. If you look there, you'll see that. Then do an integrity review. That's process steps 3 through 5. And then the assessments or MOP determination. As you look through here, you'll see steps 6 through 11. And then after you go through those, you get your assessments complete, whether you've pressure tested, where you've run ILI and done digs. After that's completed, you do your material documentation review. I would hope that would be part of your assessments as you go through. And then once you complete that and everything's acceptable, you could continue operations. And of course, depending upon what the threat was, what the concern was, you would need a process of when and if you need to reevaluate, how often. Again, this is just a picture of the chart that I just talked about. I'm not going through this anymore. You can look at it. If you've got any questions today, you're welcome to ask when I get through here now. You can ask throughout the meeting or put something on the docket. And my email will be at the end of this. You can email me if you've got a specific question. As far as existing Part 195, I suggest everyone go back and just review what the current code says on MOP determination. If you haven't looked, it's very specific today what you need to do. So if you buy a pipeline and you don't have any records, I would suggest you go look at these code sections. Or if you have a pipeline that you don't know what it is, as far as how you determine design pressure in MOP, it's spelled out in these sections. Pressure test, what you need to do there. Now, it doesn't tell you what you need to do for a spike test. Again, and then material documentation. If you look at 195, 106 on yield strength, wall thickness, joint factor, all of that's presently in the code. And then let's just talk about MOP verification with a few more details. Number one, we're looking and we want your input on some possible definitions that we may use for legacy pipe. The way we did it on the gas transmission side was it's to identify pipe that had possible seam issues, cracking type issues. And you can see what we have there, the low frequency ERW, the lap welded pipe, things like that. Then modern pipe would be pipe that didn't have seam issues, very simple. What would a spike hydrotest be? What would legacy construction techniques would be? Again, these are definitions that we've put out for gas transmission. Whether these would be the same ones for liquid, I don't know. We haven't gotten into that yet. But we would like your input on it. Again, consideration of state-specific requirements. Whatever we do is the states have the option of exceeding the federal regulations. Again, this would be the regulations on the federal side. If the state has any regulations, they're welcome to put something that exceeds it if they would like. The draft process on steps 1 and 2, the risk-based screening. Again, the screening criteria is based upon pipeline type. Offshore and in rural low-stress lines would be exempt. The screening criteria, the HCA could affect segments. We know there's approximately 83,000 miles that are HCA could affect segments. We also know there's about 2,000 miles that are less than 20% SMICE. As far as what this screening criteria would bring out, at the end of the day, we're not sure. That would be something, as I go through this, I'll show you probably some annual report data that we'll have to get. As far as the draft process steps 3 through 5, inadequate records and failure history, again, is when you get down to the number 3 box, you can see whether it's legacy or modern pipe. If it's modern pipe, you go to the left and you look at to see if it has inadequate MOP test records. Has it had a history of failures? The same thing, if it's legacy pipe, you go over and we'll have some questions there to go through. The draft process 3 through 5, again, liquid operators did not have to report grandfathered pipe or inadequate records. Of course, you don't have grandfathered pipe, but you may have the risk-based alternative type pipe. We know there's about 96,000 miles of pre-1970 or unknown decade of pipe installation. So, I would hope that the issues we're talking about here are the pre-code issues. I would hope operators would have MOP records, whether it's test records or material records, on post-code pipe. That we don't know. We also know there's about 1,000 miles of a low-frequency pipe installed after 1970. There could be more, but we do know. We hear a lot that 1970 is the cutoff on low-frequency ERW. Well, it's not. I know when I first started in the industry, you could still get low-frequency ERW, and that was after 1970. Again, is the high-end estimate on MOP verification we would hope would not be over 97,000 miles. We would hope it would be a magnitude lower than that, but we don't know. The draft process, steps 6 through 11 on MOP determination. Again, these are the same things that I've gone through before. The methods that I think we would be wanting to consider if we did write up a proposed rulemaking would be pressure test, which you can do now, a pressure reduction, engineering critical assessment, which would be quite similar to what you should be doing under EMP now, under 452, where you're using ILI on your pipelines. I would hope if you've got cracking issues, you're going through a robust evaluation of those cracking issues, that you've got Sharpie impact information on your pipeline, or you're assuming a very low number based upon industry research. I mean, if you don't know and you've got a 1949 pipe with seam issues and you're assuming 20 foot-pounds, you've probably missed the boat. You probably need to go back and reevaluate what you're doing. So, you know, a lot of these things we expect prudent operators to already be doing. So that's why PHMSA doesn't think this should be that big of a change. The method 4 would be pipe replacement. Method 5, alternative technology. And again, we want on the docket and you to come to us, what other methods should we consider? What methods should we not consider? And should all of the methods that I've got listed here be considered? To go through a little more is pressure test. Right now in the code, you know, the 1.1 or 1.25 times MOP is what's in the code. Should we consider eliminating the 1.1 and having on the liquids everything to at least be a 1.25 times the full 8 hours? The spike test segments, again, where do we use it? Is it for stress corrosion cracking, selective seam corrosion? What type of legacy issues should we be using spike tests for? And again, when we use a spike test, should there be an estimate of remaining life when you do that? And, or do we just rely upon being under INT being 5 years? What do we do there? Method 2, pressure reduction. Do you reduce the MOP by a factor of 1.25, as you can see, I've got XX there. What do we do if we let you reduce the MOP? Is that for short term that we do that? Or do we let you estimate the remaining life and just continue lowering the pressure? I don't know the answer there. Method 3 would be the engineering critical assessment. Again, that MOP would then be based upon the lowest predicted failure pressure. And again, it would be based upon segment-specific information, technical and material documentation information. You would need to analyze the cracks, the metal loss, any interacting defects to come up with the predicted failure pressure. And the MOP would be established by that with a safety factor on it. And then from that, estimate remaining life. Is this what we should do in an engineering critical assessment? In other words, what should be in engineering critical assessment? I know I've heard some say, well, ECA is similar to some other terms that's in, I think, 1104 in Appendix A. Should we change ECA analysis to some other definition? And again, if you do ILI tool inspections, that's what we would expect on this. How do you equate it to when you go in the ditch and you use in the ditch methods? How do you correlate them to make sure they're giving you the same information, or if they're off, what do you, tolerance-wise, what do you put in there? Again, method 4 and 5, pipe replacement, always an option, and alternative technology. Again, what should we look at there? And of course, if we do have rulemaking and alternative technologies in there, it would be a notification process to PHMSA with a no objection before you go forward. And any other methods to consider. MOP determination methods, again, fracture mechanics modeling would need to be part of that for your failure stress and to look at your cyclic fatigue crack growth analysis. And you can see here, these are the type things we would want to look at, is what type fatigue analysis techniques do you use? Do you look at them for ductile, brittle type? Do you look at both? When do you look at those? Which equations, which modeling would you use there? And again, when do you do a second evaluation, or is it needed? If you've got cracking, can you do a one and done? I don't think so, but I think it's something we need to talk about. And also, should we require that the results of this be confirmed by an independent expert? Or do the companies have their own experts that doesn't need to be done? Do we need to have someone that's off to the side to overlook it? I don't know the answer there, but I think that's something we would want input on. And then the last is, if we did go forward with any proposed rulemaking, what would be the timing on it? Would it be 10 years, 15 years, 20 years, 5 years? I don't know, but we would want suggestions there. What's a reasonable time limit? And then on material documentation, let's go through a few items there. What material records are needed? I think we all know you need them for MOP. I would hope you need them for integrity management. If you don't have them, I wonder how you've been effectively doing integrity management. And again, any safe operating pressures for any type of anomalies, you need to know that information. And again, this is just going through in a little more detail what those material records should be. In other words, to maintain the structural integrity of the pipeline, for the pipe design, and for integrity management. And again, if you don't know the diameter, wall thickness, grade, and seam type, how can you do integrity management? How can you do it without knowing any Sharpie impact values on your toughness if you've got cracking issues? How can you, if you are assuming 15, 20, 30 foot-pounds, how can you do that if you don't have a number of tests to show that? And also in the proper place if it's a cracking issue. And I think just going back to Robert's comment on PG&E, 30-inch seamless pipe. I've been in the industry over 40 years, and I've never heard of 30-inch seamless pipe. And when I started, we used to buy a lot of seamless pipe, and 26-inch was the largest I had ever seen that you could buy in the pipeline industry. So when he says that, he's really being nice. I would bet you a lunch that it's never been manufactured in the pipeline industry. Draft process step 12, material documentation. What should be in a material documentation plan? Should it just be pipe? Should we include valves? I mean, what if you've got a pipeline that's a 1480 or 1440 pound pipeline and you've got ANSI 300 or ANSI 400 valves in it? And I say that's happened, and it happens more than you'd think to be something lower than the rating of the pipeline. What should we do as far as components? What if you've got a fabrication and you don't know what it is? Again, the other is validated material on the main line. Should we include grade B? Should it be X42 and greater? Should there be a size? Should it be 2-inch diameter and greater? What limits there should we have? Should it just only be on the main line? Should there be any facilities, pump stations, things like that we should consider? Again, it's on the valves and components. I would hope everyone knows what their ANSI ratings are on them and that it does match up with the MOP of your pipeline. Again, cutouts. If we don't have the material documentation, if we do cutouts, how many joints do we do and how often? Is it 1 joint per mile, 10 joints per mile? You know, what should we do there? Should we be able to use in situ NDE methods? If so, what should be the procedures and the tests that we should use? That's something that PHMSA has worked with several operators on, and we have seen a number of test results. The one thing that I've told anyone that's using an in situ method, make sure you check it by destructive test methods. In other words, get samples of your pipeline, test them to make sure any in situ method you're using gives you good results. Again, should it be required on short segments? If you've got 500 feet of pipe or 100 feet of pipe, should it be different than if you've got 50 miles of pipe? And then the unique combination, different seam types, pipe manufacturers, vintages, you know, how do we handle that? possible guidelines and criteria, again, just going back through the chart and the things I'm talking about is a high level. PHMSA has not written the first word of any regulation for HL-IVP. But again, the things I've been talking about would be things that we need your input, and we will be considering if we do go forward with something. And that would be spike test pressure, D-rate criteria for an ECA program, what should be the ILI program requirements, and what do we do for material verification. Those are the key items that I think we would need input on. Again, just going through to just give you an idea on pipe and seam cracking is on the low frequency, I've got long seam, I think I made a typo there, but low frequency ERW failures chart. And you can see here, this is a research project that PHMSA funded. The work was done by Battelle, Kiefner, and DNV. And you can see whether it's the various seam types, whether it's a cold, stitched, selective seam, or hook cracks, where the failure pressure is, the chart-wise. And you can see at 90% SMICE, basically about, you're only getting about 50% of your seam defects if you're only doing a 1.25 test. And it goes up to 110% SMICE, where you would be to get 99% of your defects in your test pressure. Again, this is going back and looking at over 600 failures. You can go on our R&D website and see this. If anyone hasn't looked at it or would like to know, send me an email. I'll gladly give you a link to it. Other possible Part 195 updates that we're looking at and considering is external corrosion assessment and remediation. Should we be in requiring close interval surveys on a certain frequency? Or is everyone already doing it? You know, for IMP, you're on a maximum of a 5-year evaluation. Are you running close interval surveys every 5 years on your pipeline? If you are you just doing it in HCAs, or are you doing it for the full length of the pipeline? Is it needed? You know, that input would be good. Another is on interference currents, AC, DC interference currents. Do we need surveys in high voltage power line routings? Are you doing that now? You know, some of the new construction where PHMSA has given special permits or an alternative MAOP, and we've required an operator to do these surveys, we've seen within 3 months up to 40% wall loss and greater on some very high-profile pipelines that are large diameter. But the operators, by in the permit, in the alternative MAOP rule, has helped spell this out. When you're doing new construction, what are you doing around high-voltage power lines, and how quickly are you doing it? You know, if you're waiting a year to get your CP in, to get your ground beds in, you may in many cases be waiting too late. And then new construction. After backfill on new construction, what type coating assessments are you running? Are you running DCVG or some other type coating assessment? We've seen on alternate MAOP pipelines where down full joints of pipe, where the dozer has been run over the pipe and the operator had to go cut it out. So anyway, what should be done there? Girth weld and undestructive examination requirements. Should we be changing what's in the code now? Should we be getting it up to 100% or at least 95% and greater? What is it now? Isn't it 10%? I think that's what my memory serves me. So, you know, I would hope none of you in here are doing just 10%. I would hope the 95% would be a slam dunk, that you would come to us on the docket and say, we support that, we want that in the code. It's no cost effect. The other is we're seeing a lot of CO2 pipelines installed, or either being installed or have just recently been installed. And in the code, if you go look, if you're a CO2 pipeline owner, it says you have to have a fracture mitigation plan. But that's all it says. It doesn't give you anything on how to address operating temperatures, pressures, your product composition, pipe grade, operating stress levels for mitigation. So we think we need to put something there on how often you arrest. I mean, we have some that may come back and want it to be a mile apart, or 2 or 3 or 4 or 5 miles apart. Is that adequate on arrest of a pipeline of where you could have a running fracture? And then the last is on guided way UT assessments for short segments that you can't run an ILI tool and it's just not practical to pressure test. We would be looking at guidance to go in the code of allowing you to use that. I know now you can come to us as alternative technology and get a no objection. And we've, PHMSA's looked at hundreds of these, and it's approved hundreds of them. And we've also had on them several of the operators to go back and rewrite their plan before we've given a no objection. But should we just put these guidelines in the code rather than an operator having to go for a no objection? I think that'd be more prudent. Because, again, the vast majority are doing a very good job of this. Some of the other parts is records retention. You know, since we've got this MOP issue, should we go in and have an appendix in the code that tells you on all the records, whether it's materials, design, construction, pressure testing, or your O&M, how long you keep them? You know, do you keep them for 3 years, 5 years, life of the pipeline, 1 year? Should we spell out to where you can go to one area and look and it tell you that rather than be sprinkled throughout the code? And sometimes it'll have an exact date, sometimes it'll be an implied date. You know, that's something that we would like input. Again, just going through this, I've been up here talking about this. Again, a part of the process at PHMSA that I want to just talk a little bit is if we should go forward, what do we look at as far as impacts and benefits? Because just to tell you, Alan Mayberry and Ken Lee and myself, we don't come to the office every day and we say, what new regulation can we come up with today? You know, that's like saying, I want to go to the dentist today. You know, not many of us want to go to the dentist every day. But I mean, we do it based upon input from NTSB, input from the public, input from API, from you as operators, and again from the public. We listen to what everyone's telling us when we have these workshops and we go through this. It's not just us going to work and saying, hey, we've had a bad day today. So anyway, I want to just give you a little idea on what we look at in the cost-benefit analysis to come up with that. First of all, we need accurate data to identify the extent of the impacted pipe. And you're welcome to tell us in this docket if you've got impacted pipe, how much it'll be. I'm sure Stuart will be sending that to us from an API standpoint. He'll be giving us all those records soon. Isn't that right, Stuart? Okay, thank you. But anyway, on some of the records that we will be looking for and we'll need more on the mileage is, of course, the material records. We'll be looking for wall thickness, grade, seam type. In the use of the risk-based alternative in lieu of a pressure testing. And also if you've had a spike test, if you've got legacy constructions or pipe with manufacturing construction defects, have you had to use a spike test? And again, how will we get that? Well, we'll probably need an annual report data. We'll probably have to expand it for a year or maybe longer to get the data. It's one way. Another way, like I said, would be for industry to come to us with that information. Again, what are the expected benefits? Well, first, IVP is for pipeline accidents caused by material and construction-related defects and without pressure tests and material records. So if you've got pipelines and you don't have these issues, this rule would probably not affect you at all. The proposed rule, we will look at the cost and the benefits. And both those impacts and benefits are considered. before we go forward. In other words, we may talk about something that we would consider in a rule, but as we go and look at the cost benefit, if it's not effective, we may take something out, we may modify the diameter that it's applicable to, the percent SMICE, we go back and look at that. Some of the other impacts that it's hard for PHMSA to quantify on individual accidents is the consequences. In other words, we do get the consequences and the dollars reported to PHMSA, but some of the costs that may not be reported to us that are significant would be lost revenue and local supply disruptions, long-term remediation cost, and legal costs and penalties. A lot of those we don't get fully captured. So it really hurts a lot of times on these cost benefits when you don't have that. Some of the other data, again, this is just a chart. I've got this up more so if you look at the presentation later of if we came out with a data request, some of the information we would need. And it's the same items, MOP, seam type, vintage, if it's risk-based alternative on pressure test or not, is it in an HCA or not? So, some of these type questions that we'd be asking, if you can run an ILI tool through it or not, that we may ask if we do come out for a data request. Again, as far as the docket is open. The docket, you can go on regulations.gov, go under the docket PHMSA-2014-0150, and you can post any comments that you would like. And we do look at them. If you look here, this is some comments that we've already seen. I just wanted to put them up to give you an idea. I'm going to just touch base. One of the ones is allow sufficient time for compliance, which we would do. And you can see test pressure should be established as a percent of SMICE rather than MOP. Pressure derating should not be a long-term solution if crack threats are present. Crack threats related to legacy pipe, including early vintage, high-frequency ERW pipe, need special consideration in ECAs. Again, these are some of the comments highlighted that we've seen on our website. Here's some that says, going through there, I'm going to just pick out one or two. One-size-fits-all spike test pressure is not appropriate. ECA process needs more clarity. Industry began working with PRCI to develop an industry-wide ECA process in 2015. And let me say, PHMSA would gladly like to see the results of that and would gladly consider those in anything we're doing on this that we look forward to doing. Going down is consider 30% SMICE the appropriate threshold instead of 20%. Apply a risk-based alternative-like approach for non-HCAs. So you can see we're already getting comments. Many of you probably gave these comments. But we do go back and look on our website. We do pay attention to what's on there. Again, any questions will be here in just a few minutes. But just remember the docket, PHMSA 2014-0150 on regulations.gov as far as posting comments. Thank you, and I appreciated visiting with you today.
Thank you, Steve. We would like to open up the floor for questions. Please announce your name and affiliation. We have a microphone up here in the front and index cards if you wish to write it down. And those on the webcast, feel free to submit your questions via the link on your webcast page. So any questions for Robert Hall or Steve Nanny? Please, we welcome your questions. Okay, any questions? If there's not, I mean, feel free to write them down on index cards, or if they do come up, you know, you could save them till the end of the day at the panel discussion. If there's nothing at this time, let's go take a 15-minute break, and let's be back at 10:30. Okay, so we're going to take a 15-minute break, and we'll reconvene at 10:30. Thank you.